In our activity, we have seen that in two plastic bottles which are kept at different levels, higher and lower, the water from higher level flows to lower level, but it flows only till the time where the level of water in both the containers is same. And this means a positive charge flows from a point of higher potential to a point of lower potential. And the difference between the values of potential at points A and B is called the potential difference between them. And work has to be done against the electric field to take a positive charge from a point of lower potential to a point of higher potential. We also studied the difference in potential between the positive and negative terminals of a cell, and that is called the potential difference of that cell. And it is this potential difference that sets the electrons in motion and results in the flow of electricity through a conducting wire connected to the two ends of the cell. We also studied every atom of a metallic conductor has one or more outermost electrons which are very weakly bound to the nucleus, and these are called as free electrons. The free electrons in a conductor are the carriers of negative charge, and an electric current is the flow of electrons through the conductor. So now let us move further and study resistance and Ohm's law. The relationship between the current flowing through a wire and the potential difference across its ends can be obtained from the law that was given by the German scientist George Simon Ohm. If the physical state of a conductor remains constant, the current flowing through it is directly proportional to the potential difference between its two ends. What it means is, for some materials, the resistance is constant. A resistor that has a constant resistance is said to obey Ohm's law. And Ohm's law states that current through a metal conductor is directly proportional to the potential difference across the ends of the conductor, provided that the physical condition and the temperature they remain constant. So here current is given by I and volt potential difference is given by volt, that is V. So I is directly proportional to V. And here we take K as a constant, so I, and so that we can give the sign of equality. So I is equal to KV. Okay, K is constant of proportionality. And now we just rearrange the terms. The current I multiplied by 1 upon K. We are interchanging the position of K. Okay, so when on right side it is in the numerator's place, so when we take it in the left side it gets divided and it comes to the denominator's place. So I multiplied by 1 upon K is equal to V, and 1 upon K is nothing but the resistance of the conductor, which is R. And so I multiplied by R is equal to V, that is potential difference, which also means that potential difference is equal to current multiplied by resistance of the conductor. Or if you wish to calculate resistance, then it is potential difference divided by the current. And physical state of a conductor here means its length, area of cross section, temperature, and the material it is made up of. For example, in daily use, the wire which is used as a conductor, it is copper wire. Okay, so the length of the wire matters, area of cross section. Okay, so area of cross section here means the complete area of the wire. its cross section, and temperature and the material. Okay, because conductors, whether they are made of copper, nichrome, so it depends. And the better the conductor, they'll have more electrons flowing through it. Okay, so this is known as Ohm's law, where if the physical state of the conductor remains constant, okay, then the current flowing through it is directly proportional to the potential difference. So what matters most is that the physical state of the conductor should be constant. In that case, current will flow in an amount which is directly proportional to the potential difference between the two ends of the circuit. So now we can obtain the SI unit of resistance from the above formula. Potential difference and current are measured in volts and amperes respectively. The unit of resistance is called ohm. So it is indicated by the symbol ohm. Okay, so 1 ohm is 1 volt per ampere. So resistance of 1 ohm means if 1 ampere current flows through a conductor, when 1 volt potential difference is applied between its two ends, then the resistance of the conductor is 1 ohm. Okay, you now know what is potential difference. Okay, potential difference is the difference in the charges. Okay, so for example, it is difference in the level what we had studied in the level of water. So it is here in case of current, it is positive and negative charges, and on the opposite ends, if there are positive and negative charges, it creates a potential difference and its unit is volt. And if that potential difference is applied between two ends, okay, so if 1 volt of potential difference is applied between two ends, then how much current will flow? 1 ampere current will flow through the conducting wire, and the resistance offered by the conductor is known as, in this case, 1 ohm. Okay, so resistance and resistivity of a conductor. So there are a large number of free electrons in a conductor. As we had seen earlier, the electrons, unless and until the conductor is connected to the electric circuit, the electrons, they move randomly and they are constantly in random motion. But when a potential difference is applied between the two ends of the conductor, meaning if the wire is connected to a battery, a cell, or a direct current flow, then what happens? These electrons, they start moving, okay, from the end at a lower potential to the end at a higher potential. And this direction of motion of electron actually causes the flow of current. So moving electrons strike the atoms and ions which lie along their path. Such collisions, they cause the hindrance to the flow of electrons and they oppose the currents. And this hindrance is called the resistance of the conductor. Okay, so I repeat again, moving electrons. Okay, earlier the electrons were in random motion. Now once a potential difference is applied, suddenly they start moving. Okay, and the moving electrons, they strike the atoms and ions which are along their path. So you can take an example of a street. Your vehicle is moving. So while your vehicle is moving, there can be other vehicles or hurdles in the path. Okay, so those hurdles will offer resistance to your flow or your speed. So here also the electrons, they wish to move fast, but there are other atoms in the conductor and they cause the hindrance to the flow of the electrons. Okay, so maybe your wire has lot many electrons. Copper wire will have lot many electrons. It will allow the electrons to flow the most, but there will be certain atoms which will cause a hindrance to the flow of the electrons, and thus the electrons flow will be opposed and it will oppose the current, and hence this will offer resistance Okay, and it will account to the resistance of the conductor. So all the conductors will have certain amount of resistance. Okay, and based on that we decide whether the conductors are good conductors or bad conductors. Now resistivity at a given temperature, the resistance of R of a conductor depends on its length L, area of cross section A, and the material it is made up of. So resistance of a conductor is directly proportional to the length of the conductor. So R is directly proportional to L, and it is inversely proportional to the area of the cross section of the conductor. Okay, so it becomes R is directly proportional to L divided by A. Since it is inversely, when we say inversely, it means divided by A. Inversely means the more the area, lesser the resistance. Lesser the resistance, more the area. It is inversely proportional. Directly proportional means more the length, more the resistance. Less the length, less the resistance. Okay. So it is, and now here we add a constant. So R is equal to rho L divided by A, and rho is the constant of proportionality, and it is called the resistivity of the material. And the unit of resistivity is ohm meter. Okay, resistivity is a specific property of a material, and different materials have different resistivity. How will you prove that the unit of resistivity is ohm meter? Think about it.